Okay, cool. Looks like people are starting to pop in here. Alright. Alright, sorry about that. Man. I don't do this usually, so this is my first time ever doing a live stream that wasn't just DJing. It's a whole different beast when you're trying to actually give information to people. You get caught up in the details of putting together the plan, and then all of a sudden, the basic things fall over. It sounds a lot like programming. You're always worried about the complexity, the architecture. Before you know it, you're missing a semicolon, and your whole life sucks. Anyway. Cool. Alright, so I apologize. I'll be editing that on the other side. I'll be cutting out all the fluff, so we'll probably be starting right about here. Alright, so I'm going to start over. So, okay, today we're going to be talking about the fundamentals of Java programming. So this will be, if you're a first-time developer, this will be your first entry point into programming in general. We're going to talk a little bit about what object-oriented programming is, and that's more theory, so you don't have to take it to heart too much, but I will say that it definitely helps you understand the language better, and it's very good for the interview process later down the road. So just kind of like think about it, let it sink in, and move on. Then we're going to build our first program. We're going to compile that program, and then we're going to run that program. So you're going to get everything all here to run your first program. Then we're going to mess with that program. We're going to start hacking it up and adding different things. So, we're going to talk about different data types, accessibility, tagging your different classes and methods with accessibility identifiers. And I'll get into all that stuff and explain what it is as we go. So there's a bit, but it's going to be fun because we're actually doing stuff now. Cool. So to start, I'm going to have you go to this URL here, right? So I put it up here on this notepad already. So this is to install Java. So you're going to want to go to https://www.oracle.com/java, Java, /technologies/java se-downloads.html. Okay? So once you go there, you're going to get to this nice screen. You can also Google how to install Java, and you'll get there as well. So it might look a little different to you depending on whether you're on Mac or Mac or Windows. So I think you could just kind of go, let's see, here? I think it's here. You want the actual Java. You don't want the SDK. You might want the SDK, actually. Oh yeah, you want everything. So you want to grab one of these and just run through the installation process. There's nothing special about how to do that. So I've already done that. I haven't looked into too much as to what it installs. There's probably a lot of different stuff, but what we're going to use it for is we're going to be using it similar to how we use git commands in the last lecture. We're going to type a command, or the program, and then a command, and then maybe some other stuff. So for instance, Java C is the program that you would type to Java compile, right? And then Java is simply the runtime version of Java, so you use that to run compiled programs. So you're first going to compile the program, right? And if you remember, that's where you take your human readable code and it compiles it down to machine readable code. Then you're going to take that machine readable code and you're going to run it with the runtime program that's simply called Java. As far as what else is in there, don't need to worry about it for right now. There's a lot of complex stuff. We can start going into that later down the road. I'll be able to do some one-off lectures if anybody has some really cool information about stuff they bring up to me, or they want to learn about something and we'll just kind of figure it out on the fly. We'll do an adventure class or something. Okay, so assuming that you have completed that, if you head back over to Terminal, I assume that most of you were able to get Terminus up and running. If not, you could probably use your normal terminal. I would highly advise to get Terminus running if you're on Windows. On Mac, you can do everything with the normal terminal, but I'll be using Terminus for the purposes of this class. So once you have it installed, you should just be able to run like Java C, right? And it's gonna throw up a bunch of stuff. You're like, what the hell is going on here? Okay, so this is basically a default help menu that comes up when you haven't given it enough information. It's like, what the hell am I supposed to do? You're just telling me to run myself. Okay, cool. That doesn't make any sense. So it tells you that the usage is, this is the program name. I get to list some options I want to run it with. Basically, I can configure that instance of running this program. And I can tell it these are all the source files that I want to compile. Cool. And then these are all the options. So as you can see, there's a hell of a lot. And each one of these options may or may not have additional sub options to them. Like -D stands for directory, so you do -D space, then the directory of where you're looking to run it from. So you don't even have to run it in the directory you're in. And this is fantastic for automated co-deployment systems in the cloud, because you may have one folder that you get dumped into at the beginning of logging into that instance, and you just specify the paths of all your different applications you're going to compile in some configuration file, and then they just get kind of pulled in on the fly. It's like, okay, where's this one at? Where's this one at? But your program is running from the base directory at all times. So nothing. You don't actually change directories. You can just tell this program where to do its thing. So there's all kinds of crazy stuff you can do. And this is why I said, try to get into the habit of using your programs from the command line, because later down the road, you'll be able to do some super powerful stuff by writing little scripts that does this automatically for you. So sky's the limit, really. So anyway, we're gonna do Control L to clear that screen. All right, now we're gonna talk about object-oriented programming. Ooh, big scary words. What is that? Okay, so let's think about that for a second. Object-oriented programming. What is object-oriented programming? Okay, so obviously it's about objects. It's, we say oriented, that's directional, so that must mean that things are, laid out in relation to something, like everything's relatable in a way. Okay, cool. So objects that could kind of like map to each other in some meaningful way, and using that to make a program. Okay, so you can kind of distill things down just by thinking about what the words mean. So that's me approaching it from a standpoint of, I don't know what the hell it means, but we're actually going to figure out what it really means, okay? So let's Google that, because you're paying for me to Google for you, right? No. Object-oriented programming. All right, cool. OOP refers to a type of computer programming software design in which programmers define the data type of a data structure and also the types of operations that can be applied to the data structure. Okay, that's a lot of hefty words. But let's take a look at this first picture here. What is this? I love teaching with Google. This is awesome. Cool. So, cool. You've got a class called human. And objects have a name. It's got properties like email and address and methods. Those are functions, things that you can actually do. So you can verify, and then you can send mail, right? So humans can do these two methods. You can do a lot more, but for the purposes of this kind of gives you an idea of how to model things. So object-oriented programming is where you try to replicate reality as best you can by creating your software objects in a way where it mimics real life, and the relationships between objects identifies with how things are happening in real life. Okay, so to that end, it should be theoretically very easy to do diagrams that will you can draw it out, and then you can design your software that way. We won't be doing that in this class. That'll be the next class after we learn Java. We'll be going into software design patterns and do some cool stuff there. For now, I'm just going to go over basically what are the three pillars of object-oriented programming. The first one is encapsulation. So let's Google that. So what's encapsulation? The action of enclosing something in or as if in a capsule. Cool. So what does that mean? Well, we want to enclose our code so that other people don't know what it is. They might know what it does because they know what data they can put into it and what they'll get out, but they don't know how it does it. Now that's important for a couple different reasons. The first is, if you're writing software for me, I don't care how it works. I just care that it does work. I shouldn't have to look at the code inside. I should be able to look at what the function takes in and what comes out, and I should be able to know that that's going to accomplish my goal. So you might be writing software where I'm passing you a bunch of data, and then you're going to pass me back the processed result. I don't care how you wrote it. I mean, I do care how you wrote it, but if I'm doing a job, I want to get my stuff done as fast as possible, just like you're getting your stuff done as fast as possible, because we're all spreading our work. We're scaling it horizontally so we can all do different things at the same time and come together and build the product at the end. So that's the first reason. The second reason is, if you're coming up with code that's proprietary, meaning it's yours, it's private, and you want to be able to sell it, you don't want people to know your secret. So you want to hide it. That's super important. So encapsulation, by hiding the functionality, the actual way that things are being built underneath the scenes, you reduce complexity for yourself, your future self, because you can come back to your own code 6 months from now. You don't care how you wrote it. You just know that you wrote it and it works. Awesome. Good job. So now everything is simplified. And the object here is to build reusable Lego pieces that you can just plug in that do things, and you've already built them and tested them, so you know they do the thing you built them for, right? That's why we use other people's software too. You use Facebook because it works. You use YouTube because it works, right? Somebody designed that. It's a black box. You don't know. So encapsulation. Cool. Second one, polymorphism. What is that? Polymorphism. The condition of occurring in several different forms. Now this one is getting into biology and genetics, but let's think about that. So what we're going to end up doing is we're going to be building software that allows us to create objects that act as if they're some kind of a generic type of object, and they all can do the same thing, but they all do it their own individual way. But the rest of the system won't know that. It will treat them all as if it's the same thing. So that's the idea here, is that you want to be able to implement things in many different ways, but you want some system to be able to process it the same exact way. Because that system shouldn't need to care about the difference between a dog and a cat. That system might just want to be able to take all four-legged creatures and make them walk in a certain direction. Doesn't care how fast, doesn't care what the differences between those animals are. That system is just going to walk the cat and dog along. But the actual objects know the difference, know that they're a dog or know that they're a cat. So polymorphism is a way of having many different forms of a similar object. And that's where we get into inheritance, which is the third pillar. Now, I'm not going to Google that one because we can figure out what that means. Inheritance is what? So you get something from the previous generation. Well, in code, you have a base class, and then you can actually do what's called deriving or derivation. So you can derive a new type of object from the base object. So it basically inherits all the functionality. So in the instance of, let's think about this for a second. Okay, a creature or an animal. Let's talk about an animal object. All animals have some number of legs, from 0 to something. I don't know, want to go 1,000 for a millipede? So from 0 to some number of legs. You don't really, sometimes you don't care about how many legs it has. You just want to know how many legs it has. So you basically you put that in the base class, which is called the animal class. Creature sounds better though, it sounds more metal. Say take the animal class, and it has like a get number of legs, and it's going to return some number between 0 and 1,000 or some arbitrary number for that animal. You can pass it around as an animal, like you can give it to another system and the system can say, okay, I know this is an animal, but your dog class, it inherits the animal class, so it gets everything the animal has. So basically you can write a bunch of code and then you can make a new object that inherits all of that code. So you only have to write that generic code once. Saves you a lot of time, and it can allow other systems to treat your object in a generic way later. So that's a lot of deep diving, a lot of complexity that is probably a bit confusing right now, and that's fine because it's not really relevant to coding right now. We'll get more into that probably by the 4th or 5th lecture. We'll start to touch on some of those concepts and you'll actually see it in action. And that's where things get really, really cool. Cool. All right, so those are the 3 pillars: encapsulation, polymorphism, and inheritance. Okay? Cool. All right, you guys want to build that first program? Because I do. All right, so... All right, let's do this. So last time we made a README. We're going to leave that alone, so we're going to close that out. All right, so I assume you're using IntelliJ. So let's go ahead and open that guy up again into the program, or the project that you had open in the previous lesson. And to clarify that we had called it something like Java programming, and you git cloned it, and inside of there was the README file. So if you go back over to IntelliJ, here you go. There's README. Cool. All right, cool. So what we're going to do is I hope this works. This works for me. Make a new file. We're going to call it main.java. Now, typically your files should start with an uppercase letter if they are Java source files. So a Java file will be considered a Java source file. So go ahead and make that. Oh, look at that. I wonder if this is built into IntelliJ. It seems like it is, but it seems like it recognized that whether or not I want to add this file to Git. So I'm going to go ahead and say you can always do that, but I would just probably do it manually because you might be adding a temp file. But this is going to add it and stage it. So if you click add, you can go over here to your terminal, do git status. Hey, look at that. It's already staged it for commit. Now, you may not want to commit that, so you could always do a reset. But let's leave it for now because that's probably what we're going to want to do. Awesome. All right, so bear with me. I'm just going to kind of write this out, and then I'm going to explain it from top down. Okay? So this is going to be your first skeleton structure of a class. Of a program, I should say. And again, don't get confused. Just monkey see, monkey do for right now. So we're gonna type the word public. If you notice it's orange, that means it's a keyword. So we're gonna talk about what keywords are in a few. Then you're gonna type the word class. Now this is important. You need to type out the name of the source file, which is main, without .java. Okay. And then you're going to do an open curly brace. It should auto add one. Press the enter key. Now we're going to put some stuff between those open curly braces. We're going to do public again, the word static, right? And then the word void, and then lowercase main. Okay. So that's actually a method. So we're going to need 2 parentheses, an open and close. And inside this parentheses, there is a default set of parameters that are required for a Java program. And those that is a string array. So that's denoted by string with a capital S, an open and closed square bracket, and then I'm going to call it args for arguments. You can actually name this whatever you want because it's a variable. It just has to match the actual type that the Java programming language expects. So in this case, a string array called args. Then we're gonna do another open curly brace with a closed one. And then inside that, we're gonna type capital S and then the word system, right? Dot out dot print ln. That stands for print line. Open parenthesis, double quotation. All right, and those always have another double quotation to, close out the string. So a list of characters, letters or numbers or whatever is called a string. We'll get into that later. The parentheses are again for the function. So just like we had a function called main here, we have a function we're calling called print ln for print line. Inside those double quotation marks, we're going to do the old standard hello world. You can put whatever you want here. It can be as crass as you want. At the end, do a semicolon. Go ahead and save that. All right, that's your first program. So let's set over here, and then what we're going to do, we're going to do ls, see where we are, see what we got. Okay, so we've got a main.java. First thing you need to do here is you need to compile that. So you're going to run java c, and then you're going to start typing main. You can hit tab. Remember to autocomplete. Super nice. You're going to compile that. So let's see what happens. Nothing. Did it work? Well, let's find out. Let's look in that folder again. ls. Oh, hey, look. Main.class. Totally worked. So that's the compiled file. Okay? So what are we going to do? Well, now we want to try to run it. So I'm going to type java space main, but not the .java. Okay? Because main is the name of the program. So let's run that. Hello world. Ta-da. Cool. Now you can get rich and retire and have lots of money and stuff, and just kidding, it really doesn't work that way. But you did your first program. You print a string to the screen. Now you just have to learn how to do more and more cool stuff, and you'll be able to build some really cool programs. And if you get really good, let's start building stuff. Let's get a group together and just build some fun things. Let's do it. All right. So anyway, that's your first program. You just ran it. You did the hello world. So I want to show you what happens when everything's borked. So we're gonna go over here, and I'm just gonna take out the letter M here, and I'm gonna save that. Okay. I'm gonna recompile that. Okay. Whoops. What's this? On line 3 of main.java, there's an error. Package systa does not exist. Well, that's because that does not actually exist. It should be system. So as you can see, it knew on line 3 that this was invalid. So it gave me a nice hint. I can fix it. I can save it. I can recompile it. And the world is awesome again. This is your friend. You're always going to make mistakes. So don't be discouraged. Use the tools at your disposal. The compiler will tell you these things. There are more difficult bugs out there, a lot more difficult ones. These are called compilation bugs. There's also runtime bugs where you built your code, there's no problems, and it's running and somebody's using it, and it throws what's called a runtime exception. It crashes in the middle of running, and sometimes those can be really difficult. And there are strategies to figure out how to solve those, but a lot of them takes experience. It takes a lot of experience to kind of figure out where to look. Cool. So let's start going into some more stuff here. All right. Let's see. So we built our first program, compiled it, and we've run it. Now we're going to talk about this. All right. Okay, I'm going to go through this again. What is this program doing? Okay. Well, we've defined an application called main. And it's an application because it has this method. The Java program, which we were able to do this with, this right here, Java, that application is able to run a program that looks generally like this. It can be named anything else here, right? But it has to have this function that's public static void main that takes in an array of string arguments, and it can do anything in here, right? So this area could be millions of lines of code in various different files, but in order to run the application, it has to look like this. It can be called whatever it wants. You could even call this stuff, but you'd have to rename the file because the file has to be the same name. But let's pretend that you renamed this to stuff. Then you just type Java stuff and it would compile and run the program called stuff. Okay, so we're not going to do that. We're going to leave it as main. So don't get confused here. This is not the same as this. This is just the name of the program. This is always the name of this method here. Okay, so we've got a public class called main that has this method. That's a public static method. Okay, and it prints out hello world. So that's what this does. Cool. All right. So what are all these different keywords, right? And what's all like the architecture of this program? Like, what does it all mean? Because you're probably saying, what the hell's a class? What the hell's public? What's static? What's void? Sounds like a black hole or something, right? You know, I kind of understand that you said that this was a line of characters and, you know, this is an array, but, excuse me, what is an array? Oh, an array, it's like a bunch of things in a row. Maybe, probably. And then what is all this? This is like system out, print line. Okay, I don't even know where that's coming from. You're probably thinking, okay, so let's distill this down. Okay, so we're gonna talk about this first. There are 3 types of keywords. Okay, so I'm just gonna write a couple down here. So there, public means it's available to everybody. Okay, private, you can have a private class. Okay, you call it, I think you can call it main too. So we'll have a private class. That means nobody can access it. Okay, and there are reasons for that. There's also the protected keyword. Okay, so you have public, private, and protected. So you can pretty much understand the difference between public and private, but what does protected mean? Protected means that, remember when I said that you could have an animal object and then you could have another object that kind of makes a dog and it gets all the code that animal has for free because you said I'm going to go ahead and derive from the animal object? Well, if you mark something as protected in the animal class or the object, then that means that any derived object can get that as well. And that can be very, very powerful. We're not going to get into too much of that now, but you will end up seeing in the short run a lot of different private values. Okay, cool. So that's really public, private, and protected, which we'll get to a lot more later. Okay, so we talked about main, which is basically the entry point to the entire program, and it must be named this. Okay, so this is called a parameter. Okay, so back in algebra class, if you remember, y equals mx plus b, right? So you basically had y equals and then an equation. And the equation, you could plug in a bunch of values. You could plug in m, you could plug in x, and then b. And that's akin to parameters. Like you would pass m, x, and b into here, and you could get back y. This is the same concept in programming, and you can pass as many different parameters as you want into a function, and you can get back one result. Or you can pass back an object that has a bunch of different values in it. So right now we only have one parameter called arguments, which is a string array. But you can certainly have more than one parameter to the function, so you can do some really cool stuff. And we'll touch on that in a bit here. Okay, so this printing. Printing is your friend. So when you're writing your code and things get more complex, you're going to want some feedback as to what actually happened. And the only way you're going to be able to do that is if you print something out to the console. So generally, when you're working on a large-scale application for a company, your program will have many, many, many lines of printouts detailing important information about the state of your program, so that if something goes wrong and you get one of those weird runtime errors I was talking about while the program's running, you'll be better able to figure out where it failed over and potentially why, if you're printing out different values of the internal state of data as you go. So for now, this is going to be for printing out and testing your code, so you can kind of see that what you're doing is working. Okay. So system. This is something that comes along for free with Java. System is a class, much like main is a class. But system is a global class that's available in the Java SDK, which SDK stands for Software Development Kit. So it's a kit, like a kit of Legos, right? Except in this case, this is a kit of Java classes and objects that can do a bunch of cool stuff that can help make life easier for you. In this case, system is the class, and out is actually an object that is owned by system, and it's global, right? So this global object called out actually stands for output, and it directly links up to this terminal here. So that's why we can see the printout here, because out in Java, the output object directly can pipe all of your text, your string values right here. Okay? So you have a class called system, kind of like this, that has an object called out, that has a method called println for print line. So this function here is sort of like this function. It takes in some data, and just like this function, this function here, this function returns nothing. Like there's no like, I don't know, like we'll get to integers, but like my value equals. That's not a thing for this. So we just call the function and we don't expect any output because it just does a thing. In this case, it prints data to the console or the terminal. So that's kind of how things work in Java land, in the SDK. And there's a lot of really cool things that the Java SDK offers, and you're going to have to use some of them at some point. So as you go, I would start researching different Java objects. Like let's actually look that up so you can kind of get an example for how that works. So let's go up here, and we're gonna do Java system. There we go. Let's see what we can find here. These aren't very good. Let's see if Java system. Okay, so we're on Java 8 right now. Okay, cool. So there it is, class called system. And so if you go down, see if we can find out here. There it is. So out is actually, whoops, just clicked too many times. So out is actually a public static final print stream out. What the heck does all that mean? You're probably asking. Okay, well, let's read that. So the standard output stream. This stream is already open and ready to accept output data. Typically corresponds to display output or another output destination. Okay, cool. So it's public, so we can access it. Static means that there's only one of them. There cannot be more than one. So it's actually interesting that we run across that, because that was one of the things I want to talk about here. There's only one instance of this in memory on the computer when you're running this application. And that's because this is your core method that runs your whole application. And you only want one in memory. So your main class that you're running, it only has one function called main, right? So you can't spin up multiple copies of different things with static. So anything that's marked static, there's one copy of it and exists in memory. And it's actually more efficient too. If you know you're only going to have one, it's pretty efficient because it caches it, and caching means it stores it in memory. So if your program has to run for hours on end, it doesn't have to keep searching. It has a quick lookup to find it. Pretty simple. Final means that you're not going to modify it, right? So that means that this out does not get modified. Nobody can replace it, okay? And print stream, we don't really care too much about what that is, but if you want to look, it's really, see, adds functionality to another output stream. Yep, it's just an object that allows you to override how things are printed to the screen. So you can actually do some really cool stuff with this, but we're not going to for now. We're gonna simply use print line, which, sorry, this is the method we call, right? So we're actually calling it with a string. So print line that takes in a string, prints a string, and then terminates the line. Cool. So this area right here, this URL, I should say. Let's see if this URL works. I just copy pasted what looked to be correct. Yeah, that works. Cool. So all right. So you can go to this URL, https://docs.oracle.com/java.se/8/docs/API, and you can look up any object that you want in the Java SDK. There's a lot, so I would not recommend reading through this all on your own just for fun unless you really like dry reading, but by all means, go for it. Generally, I like to just kind of figure things out as I use them. I think to myself, I want to do something. I Google, how do I do that thing in Java? And somebody else has already figured it out. Another really awesome website that you can help. This is getting off course a little bit, but I'm gonna talk about it. So, Stack Overflow.com. So this is your friend, stackoverflow.com. You'll learn what a Stack Overflow is later down the road. But you can search anything in here, and there are so many articles of people talking about stuff. So check it out whenever you feel like you want to go down the rabbit hole a little bit or you need to solve a problem. All right, cool. So let's get back here to coding. All right. Cool. So now I want to talk about comments. When you're commenting things, or when you're writing code, you want to comment as much as possible. The reason for that is you want other people, including your own future self, to know what the heck is going on. You might write some code that's really complex, and you want to comment that because you don't want to spend a half hour trying to decipher what your own damn self wrote or what some other person wrote. You want to know exactly what they were thinking, what other little gotchas there might be, and you want to notate that so that there's a track record. It's basically for historical reference. So there's a few different ways to do that. So the first type is you do / space, and then everything after that is a comment. So I'm going to say this prints. Whoop. This prints hello world to the screen. Cool. I mean, in theory, you don't have to comment that. Most people know what that code does, but for the sake of argument, I'm going to say another type of comment here. See if it recognizes it. Yep. So this is the entry method for our application. You'll notice that a multi-line comment can actually have a /* and end in an asterisk other slash. So it sort of sandwiches those in together, right? And everything between that on multiple lines, like blah, 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 it's a whole multi-line comment, right? It's pretty cool. All right, so I don't know why it actually does all that. I'm just gonna tidy that up. Cool, there we go. And I can do the same up here, right? Cool. So I've just kind of showed you how to comment your code. Please comment your code. If you're going to work with other people and you want them to like you, you want to comment your code. Awesome. Let's see here. All right, so another thing you might have noticed is there's this little semicolon. So let's remove that, right? Let's compile that. Okay, look at that. Line 11, semicolon expected. It even tells me the line. So, okay, well, what does that tell you? A semicolon functions much like a period at the end of a sentence. You have to use it in almost all cases. You do not have to use it at the end of a function or the end of a class. Okay, you do not have to do that. But at the end of a line of code, you do, because what happens if I want to write another line of code and I do this? Cool. So let's compile that. Let's run that. Awesome. But here's the thing, you can actually do this. That looks really terrible, and I would gouge my eyes out if I had to read code that looked like that all day. But you can compile it, as far as I know, and you can still run it. So you kind of have to have that delineator there to separate things. So don't do this. Don't be that guy. No one will want to work with you. There you go. Do that, save it, and you're good to go. Awesome. Cool. Let's go to the next one. Okay. So now what I'm going to do is I'm going to make another program. I'm going to call it, let's see. Call it adder.java. Cool. So remember, we're going to do public class adder, open curly braces, public static void main string array args again. And then we know we're going to want to do a system.out.println line. So I'm going to put in some stub code for now that does nothing. Okay? But I'm going to show you how to declare variables now. So I want to add two integers together, two numbers, specifically integers. What's an integer? Specifically, I'll tell you what that is now. We'll get into more of that later, but an integer is a whole number. It's not a decimal. It's basically 0, 1, 2, 3, 4, 5, or -1, -2, -3. You can have integers that are unsigned, whereas they're not allowed to be negative. That's not this. I'm basically going to make int value 1. Yeah, I'm just going to call it value 1 equals 10. Okay. Then I'm going to do int value 2 equals 20. Okay. So I've just declared two integers. So I can basically write a bunch of code, and then I can use those values or those variables to get the data from where it's being stored, use it, or even change it, and then wherever it's stored, it's changed there, right? So I don't have to care where value 1 in the computer memory it is. I just have to say, I need you to give me space for an integer, and I need you to put this in that space. And the system's like, cool, I got you. I'll do that. And you're like, where is it? It's like, why do you care? There are cases where you do care. Right now is not that case. So we're just going to be like, nah, I don't care. That's cool. It just does something. Cool. So now I've got these values and I can do stuff. Cool. So now we're going to print that. Now, let's see if I can remember how to do this. I think you can just do, yeah, you can just do that. So we're going to basically copy paste these two lines, and we're going to do one that does print value 1, one that does print value 2. Okay? So once again, do Java C, but this time we're going to compile the adder file. Cool. All right. Then we're going to run it. Look at that. Just print two pieces of data to the screen. Okay, cool. Now we're getting somewhere. Now you know how to print something. You know how to create a couple data storage things that hold values and data, and then you can take that and show it on the console. So that's pretty cool. There's some powerful stuff you can do already. I mean, think about like word processing stuff. You can shift data around. You can copy file stuff on a text from one area on the file system, put it into a variable, and then you can print it to the console. There's all kinds of crazy stuff that you can start to do with just that. Okay, cool. Let's see, what was I going to go over next? Alright, so let's say, for instance, I want to add these two values together, and I want to print that to the screen. Cool. So let's declare another integer. Let's call it result equals. Now, I want to do the result of 10 plus 20. Now, I can do that, right? So, well, I just totally misspelled the word result. So we're going to do that again. And we're going to print out word result, right? Cool. Or the variable result. There's our data. And let's compile that. Let's print that. Okay, look. The third line was the result, 30. That is correct. But can I do this? Can I actually take that and replace it with value, which I know is 10? And can I take this and replace 20 with this. Can I do that? Fuck yeah, I can. Oops, my language. Yeah, I can. Look at that. It's not surprising, really. I mean, that's the whole point of variables, right? You want to be able to do cool stuff like that. Well, let me show you another cool trick that a lot of people think are very nice code optimizations. I like this for readability, and it's true, but the more you get into engineering, the more likely you may just see something like this. So let's compile that. Let's run that, same result. What's that doing? So it's literally adding these two variables together before it passes it down into this function called printLine. So you can do a whole bunch of operations on data as it's being passed in. It'll actually do it before it sends it down in. Pretty cool stuff that you can do there, right? So I'm gonna get rid of that line of code, right? So we don't need to print those anymore. Check it out. I'll leave those for later. Cool. So what I want to do, actually, sorry, bear with me a second. I'm going to commit this so you guys can have it for reference. So I do want to actually keep all this stuff. So I'm going to put some comments here. So prints each variable, prints the result variable, prints the addition of the variables inline. Cool, awesome, there you go. Sweet. All right, so where are we going now? Ooh, what mix is this? I don't really want this mix. Let's do something else. All right, we're gonna do this one. I think you'll like this one.
Hey, I'm Andy, and I started Harry's.
Oh, I love
a shaving
ads.
company that's fixing
They're so fantastic.
At Harry's, we keep it simple.
You guys
We
love
make
ads
sharp,
too.
durable blades
Speaking of
and offer them
ads,
at honest prices for as low as $2
Corona.
each. We obsess over
For
quality
the
so much
Corona
that we do crazy
pandemic,
things,
one of the
like buy a
last
German
ones
razor
out
blade
there
factory.
right now.
So give us a try
So,
with this special offer.
cheers.
Get a Harry starter set with a 5-blade razor, weighted handle,
All right.
shave gel, and a travel cover. All for only $3 with free shipping. Just go to harrys.com and enter 0011 at checkout. That's harrys.com, code 0011.
There's the music. All right, here we go. Okay, what was I gonna do next? Sorry. All right, I do want to show you one other variation here for printing things to the screen. So let's assume, no, that's not what I want. I want this. So let's assume that I want to say the result of value 1 and value 2 is, I should theoretically be able to do that, right? Let's find out. Look at that. Who's smart knows how to do that. Your managed languages generally can do stuff like this. This is really nice for Java, C#, Python, all kinds of different languages. However, C++ does not do that, and you have to usually end up writing that functionality for yourself. Okay, so we got nice things over here. Okay, so, but also, I don't want my thing to say value 1 and value 2. So I actually want to say the actual variables. So what I'm going to do here is I'm going to close off the string, put a plus, right? Bear with me here. Okay, now what did I just do there? I took a string, it says the result of, ended it, said add the actual variable value 1, plus another string that says and, right, with the spacing, plus value 2 variable, plus another string, plus the result. I'm going to tell you right now, this is pretty inefficient. This is not cool. If you had submitted this code to a code review at a company and somebody else looked at it, they'd be like, nah, dog. Nah. I mean, it works, but it's not efficient, because it's like, what it's really doing behind the scenes is saying, I'm creating a string, and then I'm actually appending this as a string to a string, and then I'm saying I'm going to take this string and I'm going to add it as a string to this string. And it's doing a whole bunch of like creation of strings. It's like 1, 2, 3, 4, 5, 6 at least, and that's not good. So let's do that more optimal, right? So we're gonna do, see if I remember how to do this. Okay, so there's a function in Java called string.format. I might have to Google this because I might be wrong, but essentially I can do, so let's actually just get rid of all that. The result of %d and %d is %d. Okay, you're wondering what is going on here. Okay, %d is a shortcut for string formatting that stands for an integer or a number. So in this case, we can plug in this integer here. So string format actually lets you give a string with a number of these format identifiers, and then you can pass a number of different variables into the next parameters. So I do a comma to say, okay, that's the end of the first parameter. Now I'm going to add the second one, which is value 1, comma, value 2, comma, result, and semicolon. Now I think that will work. Oh, there's also, I need one more parentheses, because there's one for this function, right? And there's one for this outer print line. So let's see if that works. Sweet. Cool. So again, I want to comment this. So prints out the entire equation inefficiently. Cool. Awesome. All right. So now you can kind of see how to create these complex strings. There's also other identifiers, and I'm going to denote those in this comment. The %s is a string. I want to say %f is a float, which you'll learn about later. I also think %b is a boolean, which you'll learn about later. Yeah, anyway, you can play around with stuff at some point, but that's essentially how you format a string. So what this does is it takes one string, it then plugs in the values, and then it's a faster operation than creating all these various strings and like plugging them together that way. It's faster to make one string and just replace the values internally with these. Okay, awesome. Cool. So I'm just gonna do some simple arithmetic operations. I'm gonna do, let's see, what do I want to test? So we've done addition, right? So let's copy this guy here. We're gonna print addition of 10 plus 10 equals, and then let's just do it the inefficient way, because I'm not. 10 plus 10.
Feel my forehead swelling.
Okay. Now I put these in parentheses here because
Under the sun.
we are saying. Remember PEMDAS? PEMDAS parentheses exponents, multiplication, division, addition, subtraction. That holds true here. So we evaluate what's in parentheses first. So this parentheses, we do this operation. So we do 10 plus 10 equals 20. Then we take that and we add it to the end of this string. So we have 10 plus 10 equals 20. So we compile that. Cool, there you go. So the reason I did that, and I'm gonna do some copy paste stuff, which I highly advise, but just be careful. If you don't change something you copied, you could be in trouble. So we're gonna do subtractions. So we're gonna do 10 minus 10, all right? Let's go ahead and compile that. Oh, like, again, look, see, just like I just said, make sure you, when you copy paste, you change everything you care about. I'm going to clear the screen too, so you can see. Okay, cool. So subtraction of 10 minus 10 is 0. Cool. So let's do that again. Do multiplication.
From a distance, I could see.
Do 10. So multiplication is the asterisk, which you may already know, but if not, that's it. And we're gonna save some time here. We're just gonna go ahead and add division. Okay. So that looks good. Let's compile that. What we got? Multiplication, 10 times 10 is 100. Division of 10 divided by 10 equals 1.
I wanted to hear the murmur.
What happens if we do
Oh, it's water again.
this? What happens if we try to make a black hole?
The sun and the strain
Find out.
and the woman's tears.
Oops.
Shade.
Now, I want you to look at this. I'm going to run it again here. I'm going to clear the screen. It ran the program,
At last.
and then it had an exception. This is one of those runtime exceptions I was talking about, right? If your program throws an exception
But as I got closer,
while it's running, your program will crash. It will stop, and that's not gonna be good for the end user. I wasn't gonna go over this, right? I wasn't gonna do this in this lesson, but since I've shown you, and I want to kind of give you an idea of how you can deal with errors. We'll circle back to this later, but I think I can do it in a couple seconds. There's a concept of an exception, and we'll cover this in more detail later. But what you do is you do something called a try-catch. So, if you think that some exception may end up happening, a runtime exception, like arithmetic exception, right? Then you can actually preemptively assume that it's going to happen and have your program take some kind of action based off of the exception that occurs. So, for instance, you do a try, and then you do catch.
I was a little surprised.
Okay, and then you can do something. So in this case,
The whole thing was over.
I can say, oops,
I'd gone there without
divide
thinking.
by 0. Let me try compiling that and see what happens here.
As soon as you
So,
saw me,
this was not on the agenda, but it is now. Look, it caught it, and it said, hey, I had an exception that occurred, and I was catching that particular type whenever a divide by 0 occurred, and I let the console, or yourself, or the person that was running the program, know what happened. So I'm going to print another line here that says,
Then he lay back.
program finished. So you can see the 2 instances of this. Let's run it. This allowed the program to finish. Okay?
Without
So
taking
what I'm
its
going to do
hands
here is I'm going to just temporarily delete this and put that code back the way it was. Essentially, I removed the exception handling that I just added. I don't see program finished.
away,
Let me run it again so you can see it.
pretty far
You don't see
away
program finished because the program blew up, failed. Okay, so when I have that, or when I add that back in there,
10 meters or so.
the program does finish. What does that mean?
Until he was
Well, that means
wasted.
that if your program throws an exception and you don't handle it correctly, your program blows up, fails, stops running, and that program that you had running on a server somewhere,
Most of the
it's
time,
done. It exits. Not
it
cool.
was just a form, shimmering before my
Okay.
eyes.
That's general error handling. That's a little advanced. Don't worry about that for right now. I'm just showing you what this is all about. Okay? So you can play around with it if you want, but I would advise you to ignore most of the error stuff I just talked about with exceptions and recognize it's a thing, because it's going to come up and hurt you later down the road. But we're going to go over exceptions and a lot more in depth in a later lesson. So this is just kind of to show you the complex things you can do with coding. So anyway, what we've done is we've gone through addition, subtraction, multiplication, and division. Cool? So I am going to erase all of this. I'm going to set this back to 10 divided by 10. Okay? And now we have the simple example, the one you really need to know about right now. Cool. All right, how we doing on time? Okay, awesome. All right, so, all right. Now I did say I was gonna wait on floats, but I'm gonna show you something right now because I think this is important to go over. We're dealing with integers right now, and all these numbers have played nicely with each other. But let's do a division. Whoop. Division that should result in a decimal. And so I'm going to do 10 divided by 3. Okay? Let's compile that. Let's clear the screen. Let's run it.
For 2 hours.
By the way, this is not really an adder anymore. This is completely misleading. Make sure to name your programs accurately. I'm going to change that later. Look at that. Division 10 divided by 3 is 3. I thought it'd be more like 3 1/3, right? So that doesn't make any sense. That's not correct. And why is that? Well, that's because integers can't hold decimals. So if you divide an integer by an integer, so division of int by an int, you get an int. It's not going to be smart enough to do the decimal for you. So now what I'm going to do is I'm going to say a decimal or a division of a decimal by an int. I think you should get a decimal. Pretty sure. So I'm going to explicitly say it's 10.0 to say that's decimal. Right? Let's compile that. There we go. This is actually funny. You might notice how at the very end it says 5, which you're probably thinking to yourself, that should be 3.33333 repeating infinitely forever. There should never be a 5. First of all, it's rounding it. Second of all, it's underneath of all of this, it's acting like what's called a float. And a float has problems underneath the hood with being accurate because computers can't actually do accurate decimals. You can only get accurate out to a particular decimal place. You may remember from science classes back in high school or college, they used to say, like, do that little line thing to say it's approximately these last couple values or something. And that's generally because computers are unable to actually track real, true precision. And so we only deal with math up to a certain precision value. Anyway. There's also some issues that can come up with this that's called floating point error. There's a lot of really weird issues, especially when you get into game graphics, where you're dealing with 3D rotations and taking objects and moving them at weird angles on their axis. You can get some crazy artifacts. I'm not going to talk about that now. If you want to know more about that, ask me on the side. There's some pretty funny stories about how this little number here can ruin your day. But let's move on. Cool. So as long as you notate one of your numbers as a decimal here, right? So you can have 10 be the integer and 3 be the decimal as well. It also works. There you go. Perfect. Cool. So teaches you a little bit about rational numbers and integer division. So why do we have integers in the first place? Why do they exist? They generally exist because they're efficient, right? Turn the music down a tiny bit. Integers are whole numbers, and therefore it's easy for the processor to do that calculation. There's no decimals. It doesn't have to do a lot of crazy arithmetic. If you remember back in long division, long multiplication, the steps that you had to do were a lot crazier. The same holds true for computer programs. There's something underneath the hood that's doing all that multiplication to try to do it as accurately as possible. And every time you do a multiplication where you have decimals, you're losing precision, and that's a hard calculation to do. Doing an integer calculation is not hard, and so it's more efficient to do that if you can store things as just integers and forget about the decimal. It's way better. Cool. All right. So now we're gonna write a function, guys. All right. So first thing I'm going to do here, I'm going to delete this adder.class. That's my compilation class. I'm going to right click on the adder.java. I'm going to rename the file. Come on. There we go. What am I going to call this? I'm going to call it variable examples. I'm going to copy that too, so we're going to need that. Okay, we're going to do refactor. And we're going to change the name of that. And then I'm going to clear the screen. I'm going to compile that. I'm going to run it. Okay, that's a better named file, right? Adder was not correct. So there we go. Cool. That's everything in this particular lecture, or is it? It's not though. We're going to create a function now. So I'm going to create public static void. I'm going to call it gallons to liters. Okay, so if this function, okay, so we're making a function that does a particular thing. We want to convert gallons to liters. Okay, in order to do that, we have to think about how that needs to be designed. This is where you start to have to think through your actual code design. The first step is how to build methods that do what you need it to do. So I have a problem. I want to automate gallons to liters. So that means that I'm taking in the gallons and I'm returning the liters. Okay, cool. That makes sense. So I'm going to pass in a float called gallons. Okay. And I have to return liters, which also is going to be a float. Remember, float is decimal. I'll go over data types later, but for now, remember, float is generally a decimal value. So if I wanted to just get some code that did something, I'd just do this. I just do 0.0. You can also specify F for float if you want to. That's valid code. Sometimes it's nice because it's explicit, so I'm going to do that. So right there, I've designed my method. It returns the wrong value every time, but it's designed. So if I was a code architecture guy, if I was the software architect, I would be architecting this code behind the scenes. And so I would fill out the function. I would say, I would be like, convert gallons to liters and return the result. And I'd be like, note, the equation is liters equals gallons multiplied by 3.7854. Okay, so if I was the software architect, I would basically say, okay, here's the method, and I'd stub out how I think it should generally, like some hints about what it needs to do. And I'd say, hey, go write this code, and then your job is to write the code and deliver it and make sure that it's tested so that whatever input I give it, it gives me back the output. So you should be able to kind of figure that out on your own, just based off of the notes and the design. So let's go ahead and do that, right? So first you're going to be like, okay, well I need to make a variable called liters, okay? And it's going to equal gallons, which is passed in, right? And I'm going to multiply it by this value. Cool. And then I don't want to return 0. I'll return liters. Okay. So let's try that out. So I don't want to do this. So float liters equals gallons to liters. There's my function. So I'm going to pass in 2 gallons. Now I've stored liters. Okay. Then I'm going to let's copy this. Okay. And 2 gallons is this many liters. Okay, let's try that out. What is this? Incompatible types. Possible lossy conversion from double to float. Okay, now let's just explicitly say that that's a float. Ta-da. That's where F comes in. It thought it was a double, which means more precise than a float. We'll get into that later, but we have to explicitly put the F there to make it know that it's a float. So we'll compile it again, run it. Let's clear the screen, run it. 2 gallons is 7.5708. That's pretty much twice that. Yep, that's it. That's exactly it. So that's it. So at that rate, I can probably just delete these because this function comments itself, doesn't it? You don't really need to leave a comment. So that's one of those common sense things. Another optimization I would say that you could do is you could take this, let's copy this, let's get rid of this, and let's do that. And you can just, ta-da, right? So you've reduced code, increased readability, and gotten the same result. Awesome. Check this out though. I'm gonna do it even nicer. Let's get rid of this variable here, and let's do that. Can we do that? Can we call the function here and have it added to the end of that string and print it? Heck yeah, we can. Awesome. Cool. Oh man. All right. This is getting kind of long. All right. I'm going to go for 15 more minutes and then I'm going to call it. And then we can pick up if we have to next time. What's up, Artemis? Cool. All right, really quickly, I'm going to show you an if statement, okay? So we've written our first function. I'm going to show you an if statement. If 5 is greater than 2, let's get rid of that space, then I want to print something out, okay? I'm going to say 5 is greater than 2, okay? Then I'm going to do another one, right? I'm going to say if 5 is less than 2, all right? So I'm pretty sure you already know what's going to be printed here. Like, that's pretty stupid, really. But, you know, in the essence of kind of just seeing what's going on, it only printed the one that said 5 is greater than 2. So that's an if statement. So that's 2 if statements in a row. Now we're going to do the same thing. Okay, so I'm going to copy paste this, and I'm going to do if else statement. So basically I'm going to say if 5 is greater than 2, print 5 is greater than 2. Else 5 is not greater than 2. Okay. This is called if else. If the first thing is true, do this. Otherwise, it's just going to do the next thing. Okay? Okay, did it again. Cool. All right. All right, this is getting really messy. Normally programs don't look this cluttered, but we're showing a lot of different examples of code, and we're going to check it in at the end of it, okay? So I'm going to copy all this, right? And I'm going to do this. I'm going to say this is an example of an if, else if, and an else, okay? So I'm going to say else if. I'm going to start off with if one is greater than 2. Now change the log to say 1 is greater than 2. Else if 5 is greater than 2, then 5 is greater than 2. Else, do that original error message, 5 is not greater than 2. So out of all these 3 possibilities, what do you think is going to happen? Pretty sure it's going to only be this one. This one should fail, should hit this one should succeed. So, as confusing as it might be, we're going to see. Let me clear the screen and run that again. Yep, we see that 3 times in a row. Cool. Okay, so you can put any numerical value in here. So you could actually say, let's actually modify this if else right? Yeah, we'll do another one. So we're going to do it as a function call with a variable. And we're going to say let's get rid of these. Okay. Let's default to everything. Right? And then we're going to say, let's say if gallons to liters, let's just say of 1 is less than 3. 1 gallon is less than 3 liters. Then let's take that same call, let's do it with 2, and let's just say 2 gallons is cool. So we already know that 1 gallon is like 3.7 something because it's right here. Right? So this is going to fail, but then 2 of these is definitely going to be greater than 3 because it was like 7.5. So this one will succeed and this one will fail. So we should be able to compile that. Cool. And then there we go. 2 gallons is greater than 3 liters. Okay. All right. So that's that. So those are if checks, and you can do all kinds of complex if checks. Generally, they're used with integers, decimals, floating points, doubles, and then the third one is booleans. This actually equates to what's called a boolean, right? So I wasn't going to talk about that now. I'm getting on a tangent again. I'm going to save that. But just keep in mind that if checks like this whole thing evaluates to a true or false condition. This is either true or it's false, and that's a boolean. So we'll talk more about that later. Cool. Okay. So the following are the logical operators that you can have, right? These are the basic ones. There are more different weird ones, but I'm going to talk about the basic ones. You can have less than, okay? Less than or equals, greater than or equals, equals, or not equals. And so we'll call these ones out because these ones you see in math, but these ones are kind of odd to programming only. So equals and not equals. So these can be used in any of these, okay? I also want to say, you can say that there's such thing as the AND operator, okay? And the OR operator. These are also a little bit complex, right? But essentially, we'll talk about these as we get further in. When you AND two operators together, you can kind of say something like 1 gallon to liter is less than 3, and like 2 gallons to liters is greater than 2. I don't know, like you could do something like that. That would mean that both of these operations have to be true for it to evaluate the true. If you do an or, it means only one of them have to be true. So I'm gonna go over those later, but you should probably know about those. So you can read up on those if you want. Okay, I'm actually gonna wrap it up. There was a couple of things that I wanted to go over, but I'm gonna roll those over into the next lecture. I'm going to post some homework, but I'm going to do that later or tomorrow, and you guys can work on it if you want to. Otherwise, please hit me up on the forum, on the Facebook group. Let me know if there's any questions. This is quite a bit to take in. It is absolutely so much, especially if you've never approached programming before. So don't get discouraged. This is really to kind of walk you through things. So what I'm going to do here, right, is Jeez. All right. Set up like crazy. Cool. All right. So I'm pushing those up to my GitHub account. I'm gonna go ahead and log in. Just want to make sure. Yeah, cool. All right, so I'm gonna go ahead and I'm gonna paste this. I'll paste it in the video itself, so you can kind of link up to it. But you'll be able to pull down the code and check it out and see all these examples. Play around with stuff. I'll give some homework, but what I do want to say is don't get discouraged. There's a lot going on here, and if you have any questions, you're always free to reach out. Work with the other people in the group to kind of figure things out and catch up. Let me know. I'll be here. I'm gonna head over to the Zoom chat, so that should be linked in the class notes. If not, I'll be adding that directly to the class page. So look for that in the next couple minutes. All right. Thanks, guys. I'll see ya.